We're picking up with the Math 1111 final exam review, and we're on the second grouping of questions where it's talking about solving equations in one variable. And the instructions for this group of questions is to solve for x in the following equations. And so if we take a look at the first one, we have 2x squared plus 16x plus 24. I immediately notice as I'm looking at this problem that I have this square. And if you remember, when you have a square, this is called a quadratic. And typically for quadratic, we have the option of factoring, or we have the option to use the quadratic formula. Now, the quadratic formula is one of those that's given to you in the formula list at the beginning of the final. So if you want to go that route, that's fine. I typically like to factor, and the first thing I notice is that all of my coefficients are even, so I can factor out a 2. So I have 2 times x squared plus 8x plus 12 equals 0. Then I need still to try to factor that quadratic inside the parentheses. I would have x times x for x squared. I need a pair of numbers that will multiply to 12 and add to 8. That's 6 and 2, and they're both positive. And then I know that one of the pieces that involves a variable, either x plus 6 is 0 or x plus 2 is 0. And then I'm going to solve each one of those respectively for x. So if I subtract 6 from either side, I have x equals negative 6, and I have x equals negative 2. So those are my answers. Again, you would get the same answers if you use quadratic formula. In my opinion, factoring is a little bit easier. Okay, question number 10 is the subtraction problem of two rational expressions. There's probably a couple ways you could do this, but the easiest way to do it is to try to eliminate the fractions. And to eliminate fractions, we multiply the entire problem by the common denominator, which for us would be 3x minus 2 times 4x plus 7. And I'm going to write this out so you can see what I'm doing. So we're going to do 5 over 3x minus 2 times 3x minus 2 times 4x plus 7 all over 1 minus 2 over 4x plus 7 times 3x minus 2 times 4x plus 7 all over 1 equals 0 times the 3x minus 2 and 4x plus 7. Okay, so then I'm going to actually do those individual multiplications there. Remember, we can divide or cancel on the bow tie. So 3x minus 2 will divide out with 3x minus 2, so that we have 5 times 4x plus 7 minus my 4x plus 7 will divide out on the second fraction, and I have 2 times 3x minus 2, and that equals 0 times 3x minus 2 times 4x plus 7. I hope you realize that 0 times anything is going to be 0. So then I'm going to go back and distribute and collect like terms, because what I've accomplished at this point is I have eliminated the fractions. So I have 20x, I'm distributing, plus 35. Okay, be careful, watch the minus sign. Minus 6x plus 4 equals 0. I'm going to combine like terms. So 20x minus 6x is 14x. 35 plus 4 is 39, and that equals 0. I'm then going to solve for x, good old basic algebra. Subtract 39 from either side. So I have 14x equals negative 39. I'm then going to divide both sides by 14. So that x equals negative 39 over 14. The next question, we have 3x squared minus 5x equals 4. And I need to solve that for x. But before we can solve for x, we have to have it set equal to 0. So I'm going to subtract 4 from either side. So I have 3x squared minus 5x minus 4 equals 0. And again, I notice this is a quadratic, and I can solve a quadratic either by factoring or quadratic formula. I think for demonstration purposes, I'm going to use quadratic formula this time, which, if you'll remember, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, again, remember where the a, b, and c come from. Remember, a is the number in front of the squared term, b is the number in front of the x or the linear term, and c is the constant. And so I'm going to basically plug and chug into that formula. So I have x equals the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 4, all divided by 2 times 3. Okay, so then I'm going to do the math. So I have 5 plus or minus the square root of 25. 4 times 3 is 12, times 4 is 48. Negative and a negative make it a positive, so it's plus 48 all over 6, which gives me 5 plus or minus 25 plus 48 is 73 over 6. Now, if possible, we want to simplify that radical. However, 73 is a prime number and won't simplify. So your answer is actually 5 plus or minus the square root of 63, all divided by 6. One more, this particular problem, x cubed plus 4x squared minus 9x minus 36. Here again, since it's a cube, there's a couple of ways you can go. One option is to see, can you group the terms together and use grouping, or do we need to use the rational root theorem? I think we can group this one. If we group the first two pieces together and make it a problem, and then group the second two pieces together and make it a problem, and work it like it's two smaller problems, I think it'll work. If we factor out an x squared from the first one, we're left with x plus 4. In the second group, I'm going to factor out a negative and a 9, and I'm left with x plus 4. I then notice that I have x plus 4 in common in both pieces. So x plus 4 is my common factor, and I have x squared minus 9 left. Now I could break down x squared minus 9 because it's the difference of two squares. And I could factor it as x plus 3, x minus 3, and that's equal to 0. One of those pieces, either x plus 4 had to be 0, or x plus 3 had to be 0, or x minus 3 had to be 0. One of the pieces had to equal 0. And so if I solve each of those respectively for x, subtract 4 from either side, I get x equals negative 4. Subtract 3 from either side, I get x equals negative 3. If I add 3 to either side, I get x equals positive 3. So we have three answers. X is negative 4, x is negative 3, and x is positive 3. All right, then I have one supplemental question related to solving equations. This one has a rational expression equal to a rational expression. Since it's a fraction equal to a fraction, we can use the concept or the idea of cross multiplication. So I'm going to multiply x minus 3 times x plus 6, and that's going to equal, and we cross multiply in the other direction, and we would have x plus 1 times x minus 2. And so then I need to do the multiplication. And in both cases, on the left and the right, since we have two pieces times two pieces, we're going to use full. So I have x squared plus 6x minus 3x minus 18. On the right side, I have x squared minus 2x plus 1x minus 2. I'm going to combine like terms on each side respectively. So I have x squared plus 3x minus 18 equals x squared minus 1x minus 2. And then I need to get all of the x's together and all of the numbers together. So the first thing I'm going to do is subtract x squared from either side so that I have 3x minus 18 equals the opposite of x minus 2. I'm then going to add x to either side to get all of the x's together. So I have 4x minus 18 equals minus 2. I'm then going to add 18 to get all of the constants together. And I'm running out of space, so I'm going over here. So I have 4x equals 16. And then I'm going to divide both sides by 4. And I get x equals 4. And there's your answer. Now, you do need to be careful here. Since you initially had fractions, you want to make sure that the value of 4 doesn't cause the denominator to be 0. It does not in either case, so the solution of x equals 4 is acceptable. That's the end of solving equations with one variable, and we'll pick up in the next video.